Hello and welcome to this video where we are going to learn how to convert a colored image into a pencil sketch using Python programming language and OpenCV library. If you are here for the first time, please consider subscribing to the channel. Also like our videos, put your comments in the comment section below and click on the notification bell so that you can be notified every time we release a new video. So let's go ahead. To start with, you need to import the requisite libraries. So we import OpenCV. In this case, we import CV2, which is an older version of OpenCV. Then we import matplotlib. Remember, we need to display our images, that is the original image, as well as the pencil sketch. And therefore, for us to be able to do so, we import matplotlib. You can also be able to display these images using as a function of OpenCV. But in this case, matplotlib, I find it to be much better in displaying our images. So run the cell by pressing Shift Enter. And the next step is to load our image. So to load our image, we need to use a function of OpenCV known as cv2.imread. So what we do is that we create a variable. In this case, I've created a variable known as img, and I have assigned it a value which is cv2.imread. And inside the parentheses of this function, I have passed the name of my image. Remember, this image must be in the same folder where you have saved your notebook. And if you're using Google Colab, you must make sure that you upload this image into your Google Colab, or if it is saved in your Google Drive, you must make sure that Google Colab is able to access your Google Drive. So run this cell. After that, we need to display our image so that you can see how it looks like. In this case, we have loaded our image using OpenCV and we want to display it using matplotlib. Now, these two use two different pixel categories. One uses BGR while the other one uses RGB. That is, OpenCV uses BGR while matplotlib uses RGB. BGR stands for blue, green, and red. RGB stands for red, green, and blue. So the key difference is how these pixels are organized in an image when you use Ether. So if you decide to display using matplotlib without converting from BGR to RGB, some colors will not come out very clearly. So we use this line of code to convert, and we use a method known as CVT color to do that conversion. Then we display our image. And once you run that cell, you can see the image of my favorite celebrity. You can also use either your image or that of your favorite celebrity. Now we go ahead and start the task of now converting this image into a pencil sketch. And as you can see, it is colored. So the first thing is to convert it into a grayscale, and we use a function or a method known as CVT color to convert it to a grayscale. So what we do is that we convert a colored image to a black and white image, what is known as a grayscale. Then we invert the grayscale image using this function known as cv2.bitwise. And once we invert the grayscale image, the next thing that we do is to blur the image. That is, we try and reduce the amount of brightness in the image, and this helps us in eliminating some unwanted background so that we don't end up sketching unwanted background. So to blur the image, we use the Gaussian blur method, which is also found in CV2. So you call the method cv2.gaussian blur, and you pass the image that you want to blur. In this case, our image here is known as inverted image. That is a variable name that we've given to our inverted image. Then you pass some arguments here or parameters that will define how well your image will be blurred. In this case, I've used the default one, which is 11110. You can be able to change it to whatever you want, and what you change it will highly influence how your final output looks like. So maybe for the first time, you can try using this default one, and as you try several other times, you can try to change these values. After that, we invert now the blurred image, and we call it the inverted blur image is equal to CV2 bitwise. We use the same method. So what we are doing is like we are trying to undo the inversion that we did here. And the purpose of this inversion was basically to help us easily blur the image and not to miss any single pixel in the image. So you can be able to run that cell. After that, we now sketch our image into a pencil sketch. And to do that, we use a method known as bitwise division between the grayscale and the inverted blur image. So we had created a grayscale image here, and here we have the final output that we got here, which is the inverted blur image. And we try to do a bitwise division of these two. So we use a method known as cv2.divide. Inside it, we pass the gray image as well as the inverted blur image. These are the variable names that we have here and here. And then we define a scale. In this case, I have used a scale of 256. You can be able to change this scale to whichever you want. We are going to do that later and see how it affects our image. Then you run that cell, and here now we have already sketched our image, but we want to see it. So we want to display it and as well display the original image so that you can be able to compare the two. We use matplotlib. So we created an object known as PLT when we were importing matplotlib. So we call the figure method to define our figure size. Then we subplot. Since we are going to use two images, we use the subplot function to separate the original plot into two categories. On the left hand side, we are going to have the original image that is known as subplot 1, whereas on the right hand side, which is known as subplot 2, we are going to have a pencil sketch image. So we define the size of the original image here, which is 18. You can be able to change the size either smaller or larger, depending on how you want it to be. We do the same for the sketch image here, and then we call the plt.show method to display our image. So once we run that, it's going to display for us two images. You can see the original image and you can see the sketch image. It's a very nice sketch. Let us now try and play around with this scale and change the scale to something like 200. Let's see how it affects our image. You can see that now our image looks a little bit more clearer, the pencil sketch. The gray concentration in the t-shirt is a little bit better. You can even change it further. Let us try and change it to something like maybe 180. Yeah, still there's better improvement. There's better improvement. So the more you change it, the better your image becomes. So you can be able to play around with that scale. Maybe one last time, and I'll change it to 150. And I believe now this is the perfect sketch that one would desire. 150 is okay for us. And with this one, you can be able to see that you can be able to play around with various functions of OpenCV and Python programming language, convert an original colored image into a pencil sketch. Thank you so much for watching this video, and please consider subscribing to the channel. Also like our videos, put your comments in the comment section below, and click on the notification bell so that you can be notified every time we release a new video. Do not forget that we have a video lined up for you on how to load images into Google Colab from your Google Drive, as well as perform various data preprocessing your images in preparation for training a neural network. We'll even go a step further and create a neural network for you and show you how you can be able to train and evaluate the performance of a neural network. So do not miss that video. It's going to come up very soon, and keep checking our channel, and you'll be notified once we release the video. Thank you.